What if the message arrived decades ago and we didn't recognize it? Not because we weren't looking, not because our equipment wasn't sensitive enough, but because what arrives after crossing 1,000 light years doesn't look like a message anymore. It looks like noise, a faint blip in the data, a statistical fluctuation, something you could spend your entire career analyzing and never be sure if it's signal or artifact. We imagine contact as obvious, a clear transmission, unmistakable, something that announces itself. But that image assumes the message crosses space intact. It doesn't. Space dismantles meaning. Redshift stretches frequencies. Interference buries patterns. Entropy smooths out structure. The universe is not a neutral medium for communication. It's hostile to it. Every force, every field, every particle between here and there works against coherence. So maybe they did call, maybe they're calling right now, and maybe the message that reaches us is so degraded, so faint, so tangled in the background noise of the cosmos that we will never ever know we received it. The silence we hear might not be silence at all. It might be the sound of physics winning. I want to take that possibility seriously, not as speculation, not as pessimism, but as a consequence of what we know about how information behaves when it crosses the kinds of distances that separate stars. Because if we're honest about the physics, really honest, not hopeful, we arrive somewhere uncomfortable. Somewhere that suggests the search for extraterrestrial intelligence isn't a problem of better technology or longer patience. It's a problem that sits at the boundary of what communication can mean when the communicators are separated by gulfs so vast that time itself stops being something they share. Let me start with the thing we take for granted, the speed of light. 299,792,458 meters per second. At human scale, it's effectively instantaneous. You flip a switch, the light turns on. No delay you can perceive. But space is not built at human scale. The nearest star system to us, Alpha Centauri, is 4.37 light years away. That means light from there, the fastest thing that can carry information in this universe, takes 4 years and 4 months to reach us. A radio signal sent from a planet orbiting that star today wouldn't arrive here until 2030. And Alpha Centauri is our neighbor. It's right next door in cosmic terms. Most stars are hundreds or thousands or tens of thousands of light years away. The center of our own galaxy is 26,000 light years distant. A signal from there, traveling at the absolute speed limit of the universe, would arrive 26,000 years after it was sent. Now think about what that means for the idea of calling. When we use that word, we're importing assumptions from human experience. A call is a real-time exchange. I say something, you hear it, you respond, I hear your response. There's a flow, a back and forth. The delay between my words and your hearing them is so small we don't even notice it. Even a phone call across the planet has a delay measured in fractions of a second. That's what calling means to us. It means shared time. It means we're both present, both in the same now, connected by a channel that preserves that simultaneity well enough for conversation to be possible. But at interstellar distances, shared time is a fiction. If I send a message to a planet 1,000 light years away, it will arrive in the year 3026. Not eventually, not after a long wait, in the year 3026. 1,000 years of history will pass on Earth between the moment I send that message and the moment it could possibly be received. Empires will rise and collapse, languages will be born and die. The entire social and technological context that made the message meaningful will vanish, and if they respond immediately the moment they receive it, that response will arrive back here in the year 5026. 2,000 years round trip. Whatever I asked, whatever they answered, we are not having a conversation. We're leaving artifacts for civilizations that don't exist yet. This is not a technical problem. You can't solve it with more power or better antennas or clever engineering. It's written into the structure of space-time itself. The speed of light is not arbitrary. It's the rate at which causality propagates. It's the speed limit of cause and effect. Einstein showed us that space and time are not separate things. They're woven together, and the speed of light is the exchange rate between them. When you travel through space, you travel through time. When information crosses distance, it crosses duration. And at cosmic distances, that duration is so large that the word conversation stops referring to anything real. Let me make this more precise. Suppose there's a civilization 500 light years away, and they've been broadcasting a signal toward Earth for the last 600 years. That signal is in transit right now. It's been traveling for 6 centuries, and it'll arrive here in another century or so, let's say around the year 2126. Now ask yourself, who sent that message? Not individuals, obviously. Individuals don't live 600 years. But also, what civilization? The one that exists now in their present is not the one that sent the signal. That civilization is 600 years older than the senders. For all we know, the sender's civilization collapsed 400 years ago. Or they evolved past the need for radio. Or they went silent by choice. Or they're simply gone. The signal doesn't care. It keeps traveling. It arrives at the destination regardless of whether the sender still exists, regardless of whether the sender's entire context still exists. A signal is not a message in the sense we mean it, it's a fossil. It's evidence that something once happened. But the thing that happened is separated from the evidence by a gulf of time so wide that calling it communication is almost a category error. And here's where it gets worse. Because even if we accept that this isn't conversation, even if we accept that we're talking about messages in bottles, flung across time and space with no expectation of reply, there's still the question of whether the message survives the journey at all. And the answer the physics gives us is probably not intact. Not in any form we could confidently decode. A signal is information, and information, in the physical sense, is a pattern, a deviation from randomness, a structure that stands out against background noise. When you send a radio signal into space, you're sending a pattern of electromagnetic waves, peaks and troughs, frequencies and modulations, encoding whatever you want to say. But that pattern has to cross space, real space, not empty space, not the idealized vacuum of a textbook, but the actual universe, which is full of things that disrupt patterns. First, there's the inverse square law. As a signal spreads out from its source, its intensity drops with the square of the distance, double the distance, and the signal becomes 4 times weaker. 10 times the distance, 100 times weaker, 1,000 times the distance, 1,000,000 times weaker. By the time a signal crosses interstellar distances, it's unimaginably faint. The most powerful transmission we could generate with current technology, let's say we use the entire output of a large power plant and focus it into a directional beam, would arrive at Alpha Centauri with a strength measured in billions of a watt per square meter. At 1,000 light years, we're talking about something like 10 minus 30 watts per square meter. That's not weak in the sense of hard to hear. It's weak in the sense of indistinguishable from the thermal background radiation of space itself. Then there's redshift. As space expands, and it is expanding everywhere, all the time the wavelength of light traveling through it gets stretched. The farther the light travels, the more it's stretched. For a signal crossing thousands of light years, this means the frequency you sent is not the frequency that arrives. A signal broadcast at 1,420 megahertz might arrive at 1,410 megahertz or 1,400 or lower, depending on distance and the local expansion rate. If you don't know the exact distance and the exact original frequency, you don't know where to look. And even if you find something, you have to correct for the shift, which means you need a model of how the signal was redshifted, which means you need to know where it came from and when. You're solving for multiple unknowns with incomplete information. Then there's scattering. Space is not empty. It's full of gas, plasma, dust, charged particles. When an electromagnetic wave passes through ionized gas, which is everywhere in the interstellar medium, it gets refracted. Different frequencies get bent by different amounts. The signal that arrives is smeared, blurred, like a photograph taken through a dirty lens. The technical term is dispersion, and it's worse at lower frequencies. That's a problem, because lower frequencies are exactly what we'd expect an alien civilization to use. They penetrate atmospheres better, they're easier to generate at high power, and they travel farther before being absorbed. But those are also the frequencies most vulnerable to dispersion. A carefully encoded message sent at low frequency might arrive as an unreadable blur, all its structure washed out by the turbulence of interstellar space. And then there's noise. The universe is loud. Not loud in the sense of sound, there's no sound in vacuum, but loud in the sense of electromagnetic radiation. The cosmic microwave background is everywhere, a faint hiss left over from the Big Bang, filling every cubic meter of space with radiation at a temperature of 2.7 Kelvin. Stars emit across the entire spectrum. Galaxies emit, pulsars emit regular, intense bursts that look, at first glance, exactly like artificial signals, so much so that when we first detected them in 1967, we briefly thought we'd found aliens. Gas clouds emit, black holes emit, the universe is full of radiation, and all of it is noise if you're trying to detect a signal. A faint transmission from a distant civilization has to compete with all of that. It has to be strong enough, structured enough, persistent enough that you can pick it out of the noise and say with confidence, that is not natural. That is a pattern that could only have been made by intention. But here's the thing. Intention is not a physical property. There's no equation that outputs this was made by an intelligence. There's only pattern and deviation from expectation. And at the threshold of detectability, when the signal is so faint, it's barely above the noise floor, the difference between pattern and accident becomes a question of interpretation. You see a spike in the data. Is that a signal, or is it a cosmic ray hitting your detector? You see a repeating pulse. Is that a transmission, or is it a pulsar you haven't cataloged yet? You see a narrow band emission at an unusual frequency. Is that deliberate, or is it a natural maser amplifying background radiation in a way we don't fully understand? The closer you get to the noise floor, the harder these questions become, and a signal crossing thousands of light years is always going to be close to the noise floor, always. So now combine all of this, take a signal that was already faint when it left its origin, let it travel for 1,000 years, spreading and weakening according to the inverse square law, let space expand while it travels, stretching its frequency into a range you might not be searching. Let it pass through clouds of ionized gas that scatter and blur its structure. Let it compete with the electromagnetic noise of 1 billion stars, 1 trillion gas clouds, the background hum of the universe itself. What arrives is not the message. What arrives is the tsenhe of the message, a faint, distorted echo, so degraded and so tangled in noise that the question, is this a signal, has no clear answer. You can analyze it, you can run statistical tests, you can look for patterns, but you will never be certain. The physics has taken certainty away from you. And this is what I mean when I say the universe is hostile to communication at this scale. It's not that it's difficult. Difficult things can be solved with enough effort. This is structural. The universe does not preserve meaning across these distances. It erodes it systematically, lawfully, in ways you cannot engineer around because they are consequences of how space-time and electromagnetism and thermodynamics work at the most fundamental level. Let me give you a number. The wow signal, the 15th of August, 1977. A radio telescope in Ohio detected a strong narrow-band signal at 1,420 megahertz that lasted 72 seconds. It was so unusual, so striking, that the astronomer analyzing the data circled it on the printout and wrote wow next to it. To this day, it remains one of the most promising candidate signals we've ever detected, and we have no idea what it was. We looked again many times with better equipment. We never found it again. Was it a signal from an alien civilization? Was it a reflection of a piece of space debris? Was it interference from a terrestrial source we never identified? Was it a natural astrophysical phenomenon we don't have a name for yet? We don't know. We can't know. The signal appeared once and never repeated, and that single appearance doesn't give us enough information to decide between hypotheses. It's the perfect example of what I'm describing, something that might be a message, might be noise, and the universe gives us no way to tell the difference. Now ask yourself, how many signals like that have we missed? Not because we weren't looking, but because they were below the threshold we were searching, or at a frequency we weren't monitoring, or during a time we weren't observing that part of the sky. We've been listening for 70 years, but we haven't been listening everywhere at every frequency all the time. We've been sampling, taking snapshots. A signal could arrive, persist for hours or days or weeks, and vanish before we happen to point a telescope in that direction. Or it could arrive so degraded that it never rose above our detection threshold at all. It could be in the data we've already collected, buried in terabytes of noise, a statistical fluctuation we glanced at and dismissed because it wasn't quite strong enough, quite clear enough, quite persistent enough to justify further investigation. The absence of a confirmed detection does not mean the absence of a signal. It means we haven't found a signal we can confirm. Those are not the same thing. And here's where the word aliens does the heaviest work. Because we've been talking about signals and physics and information theory, but underneath all of that is a question about what it means for someone else to be out there. We imagine aliens as beings like us, scaled up, civilizations that build and transmit and wait for replies, operating under the same assumptions about communication that we do. But if the physics makes real-time communication impossible, if every exchange is separated by centuries or millennia, if every message that survives the journey arrives degraded and ambiguous, then what does it mean to say they're calling? What is a call that you send, knowing you will never hear a reply, knowing the recipients may not exist by the time it arrives, knowing the message itself may be unrecognizable when it gets there? That's not a call in any sense we understand. It's a gesture into the void. It's an expression of existence, not an initiation of contact. And maybe that's all it can ever be at this scale. Maybe the silence we've been interpreting as absence is actually the sound of countless civilizations gesturing into the void, and all of those gestures arriving too faint, too late, too distorted to be recognized for what they are. There's a deeper problem, and it's one we haven't faced directly yet. Even if a signal arrives intact, even if, against all odds, it crosses the distance without being drowned in noise, without being scattered beyond recognition, without being redshifted out of our search band, we still have to decode it. And decoding requires context. It requires shared assumptions about what constitutes meaning, what constitutes structure, what constitutes a message at all. When you and I communicate, we share an enormous amount of context. We share a language, or at least overlapping languages. We share concepts. We share a physical environment that gives us common reference points. We both know what a day is, what a year is, what heat and cold and light and dark mean. All of that context is built into the way we encode meaning. But an alien civilization shares none of that. They don't have our physics. Well, they have the same fundamental physics, but they may have discovered it in a different order, may describe it with different mathematics, may emphasize entirely different aspects of it. They don't have our chemistry, our biology, our evolutionary history, our sensory modalities. They don't have our languages, our cultures, our metaphors, our way of breaking the world into categories. A message from them would be encoded in a framework we don't have access to, and without that framework, the message is just data. It's a sequence of symbols with no key. We assume that mathematics is universal, that any intelligent species would discover the same basic truths, prime numbers, pi, the fundamental constants. And maybe that's true. Maybe you could build a message around those commonalities, a sort of primer that establishes basic concepts and builds up from there. That's the idea behind the Arecibo message we sent in 1974 and behind the plaques on the Voyager probes. But even that assumes a kind of intelligence that thinks in terms of symbols and sequences and logical buildup. What if their cognition is nothing like ours? What if they process information in a way that doesn't map onto sequential logic, doesn't parse into discrete symbols, doesn't build meaning the way we do? Then even a mathematically encoded message might be incomprehensible to them and theirs to us. Not because either of us is stupid, but because we're solving different problems with different cognitive architectures, and the overlap is smaller than we think. And that's assuming they want to be understood. Maybe they don't. Maybe the signal isn't for us. Maybe it's for someone else, and we're overhearing a conversation we were never meant to be part of. Or maybe it's not a message at all in the sense we mean it. Maybe it's leakage, the radio equivalent of light pollution, the unintentional radiation of a technological civilization going about its business. We leak radio, our television broadcasts, our radar installations, our satellites, all of that bleeds into space. It's not aimed at anyone. It's not encoded for clarity. It's just noise from our perspective, but from the outside, it might look like a signal. If an alien civilization detected our leakage, they'd face the same problem we do. Is this intentional? Is this a message? Or is this just the noise of a civilization that happens to use electromagnetic radiation for its own purposes and doesn't care who else might be listening? The more I think about this, the more I'm convinced that the question, why don't they call, is the wrong question. It assumes calling is a thing that can happen at cosmic scale, and I'm not sure it is. Communication requires a channel that preserves meaning. At interstellar distances, space itself destroys the channel. Time destroys the channel. Physics destroys the channel. What's left is not communication in any functional sense. It's transmission without reception, or reception without comprehension, or comprehension without confidence. It's an asymmetry so severe that the word communication stops applying. And if that's true, if the structure of the universe makes communication incoherent at the scale where it would matter, then the silence is not a mystery, it's a consequence. It's what we should expect. It's the only possible outcome. I don't find that comforting. I want to be wrong about this. I want there to be a solution, some clever trick of physics or engineering that lets meaning survive the crossing. But one thing doesn't change what the equations say, and what they say is that distance is not just separation in space, it's separation in time, separation in context, separation in the possibility of shared now. The farther apart two things are, the less communication between them can mean anything. And at the distances that separate stars, the concept breaks down entirely. So maybe they are calling. Maybe the sky is full of signals right now, broadcast from 1,000 civilizations, all of them shouting into the void because shouting is the only thing they can do. And maybe we are receiving some of those signals, faint, distorted, unrecognizable, buried in noise, indistinguishable from the background hum of a universe that is anything but silent. Maybe the wow signal was one. Maybe there are others in the data we've collected, waiting for someone to notice, waiting for someone to find the pattern, or maybe there's no pattern left to find. Maybe the physics won the moment the signal left its origin, and what arrives here is no longer a message in any sense that matters. Maybe the silence we hear when we listen to the stars is not the absence of others. Maybe it's the presence of distance. Maybe it's the sound of light years doing what light years do, making here and there into categories so absolute that even information cannot cross them intact. And if that's true, then we are alone, not because we are the only ones, but because the universe makes aloneness structural at this scale. We are alone because together requires shared time, and time stops being shared when distance gets large enough. We are alone because communication is a concept that only works locally, and we are trying to apply it globally. We are alone because the physics that governs everything we are and everything we can ever detect says this far, no farther. Not as punishment, not as mystery, just as law. I look at the sky, and I know there are billions of stars out there and billions of planets, and the chemistry that made us is the same chemistry everywhere, and the odds say intelligence should be common. I know all of that, and I also know that knowing it doesn't matter, because knowing and meeting are separated by a gap that physics will not let us cross. They might be out there, they probably are. And we will never speak to them, not because we lack the will or the technology, but because speaking requires a shared now, and the universe does not provide one. The silence is not temporary. It's not a problem waiting for a solution. It's the final word on what it means to be intelligent and alone in a cosmos where distance is the same thing as time, and time is the same thing as isolation, and isolation is written into the structure of space-time itself. That's what the physics says. That's what no one talks about.